So this video is to give you some insight into what is the critical factor doing. And so as a reminder, the critical factor is the ratio of the cost of underage over the cost of underage plus the cost of overage. And so it balances the expected costs of these two things. And you could think about this critical factor, which will always be a value between 0 and 1, as a target service level. And so a service level is the probability of filling an order for one item from the current stock. And the stock at risk is the probability of not filling an order for one item from the current stock, which is 1 minus the service level. And so if we examine the critical factor, one thing to say is, let's say we calculate the critical factor as 80%. What does that mean? Well, mathematically, that means that the probability that all the customer demands in the selling period get filled is equal to 80%. It also means the probability that demand is smaller than or equal to Q is 80%. That's because we can only sell something if we have it. And so you can think about that as the critical factor. And so we are setting the critical factor, and then we're determining Q. So what that means is we're trying to set our service level, and then using that service level to say, on average, the probability that all the customer demands in a selling period are filled is the critical value. And so what that means, if your answer is 80% of the time, the customer's demand is satisfied. You may think that's an interesting way to run a store. Don't you want to satisfy 100% of your customer's demand? And the reason that that is not the case is there is a cost of having too many. And so because the inventory at the end has to get marked down, you don't want to satisfy 100% of your customers unless you have no uncertainty in your customers. And so that's an interesting kind of observation, is that the best, the optimal, is actually to say 20% of the time we're not going to be able to serve you. And so the in-stock probability is the probability all demand is satisfied. And so here, if we determine that 80% that is associated with a Q of 3,000, then to satisfy all demand, demand must be 3,000 or less. And that's what the cumulative distribution function tells us. And so you can think about the critical value is it provides us with the in-stock probability. And so graphically, I think this works for any distribution, but let's just use our normal distribution, something we're familiar with. What this means is we are setting Q, that's this line here, such that on the left-hand side, that means 80% of the area under the curve means we will meet demand. In other words, we will have excess inventory because we meet the demand. And on the other side, on the right-hand side, 1 minus the critical factor is the probability of not meeting demand. And so you could ask questions, is it correct to set the service level at 80%? And if your problem has overage and underage, and you calculate the critical value, then yes. If you calculate the critical value at a different answer, let's say it's 0.7 or 0.9, that will be influenced by the ratio of underage and overage cost, and that's how you should set it. But you may think, shouldn't we aim to provide 100% servability? The issue with that is that would mean we'd move Q over. And so the probability of not meeting demand would be 0, but we'd have lots of inventory left over, which costs us stuff. And so the answer is no, we shouldn't aim to have 100% servability if your critical value is calculated as less than